everyone. Thank you so much for joining, and this is our AWS Cloud session. So, this is more for the AWS people that we have over here. So, yeah, I hope that you guys enjoy this. Hi, Abhishek, how are you? Uh, so we have some fantastic speakers. You met the speakers for Azure, and now we will have them for AWS. So, yeah, I think I will bring them up. Um, Harish and Kavya. Yeah. So, hello Harish, hello Kavya.
Yeah, I'm sure. Can you able to hear me?
It's a little muted. I'm not sure why.
But I couldn't able to hear you. Wait, I'll just rejoin.
Yeah, Harish, hi.
Hi. Can you hear me, bro?
Yes, your voice is actually more clear.
Okay.
Um, yeah. Uh, so yeah, I think I will leave you guys. So Harish here and Kavya, they will both be taking the AWS session. I hope that you get some amazing insights from them. And I think you can present your screen and start. I will just remove myself from stage if that's okay. But if anything you
Yeah,
need,
sure.
I'm just right over here.
Okay. Yeah.
Okay.
My voice is clear, right?
Yes, it's perfect.
Okay.
Am I perfectly audible without any some background noise?
Yeah, it's better, but now it's lower. It's perfect, but if you could increase the volume, it would be even better.
Yeah. If it is okay now, is it okay now?
Guys, if you could comment on the chat box and say if this much is fine. Yeah, Yonos is also telling the same thing actually, that your voice is pretty low. Is there any way you could change the volume of the
Okay.
microphone?
Sure, I'll join again. I'll change mine and join.
Yeah. You should have an option to change the microphone without joining. Actually, you can probably use the three dot menu over here, go to audio video settings. So, yeah.
Is it okay now?
I think it was better earlier.
Oh, yes, I have changed mine. Is it fine now?
I think we will have to do with this, no issues. So, yeah,
Okay, fine.
perfect. Thank you. So, I think Harish, you will be going first or Kavya will be going first?
Kavya will be doing first, and I'll be
Okay,
continuing
perfect.
with it.
So, yeah, perfect. So, I'll leave you guys to it.
Okay. Can you all able to hear me? Harish, is my voice okay?
Yeah, it's clear. It's clear. Yeah.
It's clear, right? Okay, fine.
Yeah,
Then
it's
I'll just
clear. But
proceed.
if you could go a bit louder, it will be much better.
Yeah, okay. I'll just raise my voice and speak louder.
Yeah, it's perfect now. It's perfect.
Oh, okay. I just share my screen. Is my screen visible?
Yeah, it's
Is my
visible.
screen visible?
Yeah, yeah,
Okay,
it's visible.
okay. And I'll proceed now. And today's session is nothing but all about AWS. Wait, I just on my video. I just forgot it. Okay, fine. You could see the screen, right?
Yeah, it's visible. Yeah.
Okay, thanks, Harish. And today our session is entirely about the AWS, which is the Gen Cloud Service Provider. And first of all, before diving to the services under AWS, I'd like to give you a short gist on the like what is the basically the cloud computing is and some of the basic stuffs before diving into the services. Today we are going to see the agenda. Main agenda for today is we are going to see the overview of what is exactly is cloud just for around 5 to 10 minutes, and then we'll be proceeding with services under the AWS, and specifically we'll be just going through the storage service because there are a number of services which AWS provides. But as far as the time is concerned, I like to tell about the AWS service, and my friend Harish will continue the rest of the services in his session. So let's dive into the session, and initially let's see what is cloud computing. I'm audible, right?
Yeah, you are audible. Yeah.
Okay, fine. So let's see what is exactly about cloud computing. It's nothing but the on-demand delivery of either compute power or database storage or any other IT resources via the cloud services platform. Maybe it may be of AWS and Microsoft Azure provided by the Microsoft, as well as it may be the Google Cloud platform under the Google Cloud, which is provided by Google. So everything here seems to go as in the way of pay as you go pricing, because we are not going to set up any servers when there are a lot of requests. We are going they are the cloud service providers, they have a lot of resources. We are going to just pay for the resource what we are just using at that particular instant. We are not going to purchase a lot of things, and we don't want to set up the capital infrastructure. We are just only focusing on the operational infrastructure so that we could able to do a better applications rather than just focusing on running the servers for around 24 bar 7 hours. We are just going to focus on the innovation, not considering the running the servers and maintaining those servers. So that's what's the concept of the cloud computing. So coming back to the major cloud service providers, as far as nowadays, there are three major cloud service providers which everyone are using, which is nothing but the AWS and Azure as well as the GCP. But today in our session, it's actually about AWS. So we are going to say about the AWS services. So coming to the overview of the AWS services, it's actually a variety of services are available for setting up the storage, for networking purpose, and for remote computing, for mobile development, and for email notifications, which is nothing but SMS comes to picture, as well as for storage, the Amazon S3 and block storage and file system storage comes to picture, and for compute there is EC2 and Light Sail, and there are a number of services which comes under each and every domain. In fact, the security is also highly maintained for those kind of services, so which gives a trust for the users to give their personal information, because the credit card details and those kind of stuffs must be stored securely. So those kind of security services also provided by the AWS. So next, coming to achieving availability. So here comes the question: why AWS is occupying a lot of people's revenue market? Like, why many companies opt to use AWS is that because of the reason of achieving the availability. Why? Because is that there are a number of data centers which are compared to other service providers. There are a lot of data centers available globally. So coming to the data centers, it is further classified as the availability zones, the region, the edge locations, as well as the regional edge caches. So we'll be just seeing everything in a gist. I'll just give you outline of what everything is. So first, coming back to the region. Region is nothing but the separate geographic area, and globally there are a lot of regions. In this graph, you could see the blue hotspots, which is denoted in the circle or the regions, and each regions consists of the one or more availability zones. So if there
Kavya,
occurs some,
your slide is not changing in the first slide.
oh, wait, is it changing now?
No, it's not changing.
One
Yeah,
second,
yeah,
I'll
now it's changing. Now it's changing. Now it's changing. Yeah.
in the presentation mode,
Uh,
it's not changed, I think so.
yeah, now
Actually,
it's
I
changing.
was
Yeah.
okay, fine. Then I just proceed in this style itself. I will not be turning to the full screen mode. I think there's some issues regarding that. So first, I was saying about this cloud computing introduction. Then I was telling about the rest of the service providers, and then I gave the overview. And this is what in this particular slide. And now coming to the achieving availability. This is what is going on. So now we have seen about the regions. In this graph, you could see, that is in this global graph, you could see a lot of blue hotspot regions, which is nothing but the regions, and each and every region consists of two or more availability zones. The reason for the availability zone is that to
Um,
maintain the backup of the data.
Hi, Kavya. Sorry to interrupt, but Ashwin is telling that screen is not changing. Can you please look into it?
Ah, yeah, sure.
Yeah, actually, before it was not changing, but now she has fixed it. So now it's
Oh,
In the
changing.
full
perfect.
screen
So,
mode. Oh, okay, fine. Actually, I shared a particular window, so if it's not changed, I think if I
okay.
have shared my whole screen, it will might be changing. I think it's
Perfect.
now okay. Okay, fine. So under a particular region, there are one or more availability zones. So this use of this AZs is that to get the backup of data during some disaster recovery, so that they could have multiple copies of data within a particular region, and this what everyone seeks for, because if something goes wrong, there might be another way to get back the data, that is our data. So that's the reason why the high availability is achieved by using this kind of regions as well as the availability zones. So next, coming back to the edge locations. Edge locations is concerned or mainly because of using the service that is CloudFront for low latency delivery of the information. So that's what is the main key point under the edge location. And here, this is the overview of the picture of what exactly is the region, and the region comprises of the availability zone, and the RDS, all those kind of database are present in the availability zone, and the availability zones as well as that's the region is connected to the local zones. Local zones is also a part of the region. So that's what is depicted in this picture, which is from the AWS documentation. So coming back to the AWS region, as I have said, there are a lot of AWS regions available, and here's a sample list of that. And here you could see for under US there is four regions, which is nothing but the East, West, and in Ohio, that is Ohio region, and Northern Virginia region, and Canada, South America. There are a number of regions. Just for example, I have shown here. And next, coming back to the availability zone, in the previous slide, you saw that the region is specified as US East, and and if it is then preceded by that is one or some numbers, it's a denotation of the availability zone. That is, it may be either 1A or some 2A. Everything has some notations, so by this we could identify the availability zone, and this is what is nothing but the AZs and the regions, and this is the main concepts. And as I have said, the local zone is also an extension of the AWS region, that is geographically close to the users, because to achieve the low latency network. So if the main goal of the all the giant service providers is to give the access to the users in low latency, because no one likes if there is a maximum delay of getting the data. It would be better if the delay is less. So that's how it is achieving by using this kind of AZs as well as the local zone. And coming back to the edge location, it's nothing but the cached data centers. So it's also is helpful to achieve the lowest latency, and this is used in with the connection of the services as CloudFront, Route 53. All this kind of services comes under the network. So if you're just a beginner, just don't bother a lot about it. This is a quick introduction of the basics. So this is how the infrastructure of the AWS looks like, and these are the main key points to be noted before diving to study our services. So once you're clear about the framework and infrastructure, that is, if you have some clear idea on what exactly is cloud and how they're achieving these kind of security and how it is possible to maintain the availability and scalability, if the concepts are a bit clear regarding these kind of things, then you could dive further to study about a particular service in detail, which will be very easy for you to just remember, and all those kind of stuff will be easy further. So that's why I'm just giving you an overview of what exactly is the infrastructure here. So, as I have said, the edge location comes to the picture along with the CloudFront, Route 53, and Web Application Firewall. So, when these kind of services are used, the edge location is comes to picture, and that's what is mentioned here. So, as far as beginners are concerned, you just know what is exactly is region and what exactly is AZs and what exactly is edge location, and that's it for this. And now we have seen what exactly is the availability and how they are achieving the availability and those kind of things we have seen now. And now next diving into the AWS service, there are a lot of services, but all these services are grouped under a particular domain. So you can see like under compute you have a like 7 to 8 services, which is nothing but the easy to, and there are many number of services. And under storage there are like a lot of services like Amazon S3, which is nothing but the simple storage service, and EBS, which is nothing but the block storage, and EFS, which is nothing but the file storage. And in the similar way, there are machine learning services also. All these build the models which can be done very easily with some few clicks. We could configure the parameters according to our way, and if it was done manually it would take a lot of time to train the model as well as to train and test the data, and all those kind of stuff will take a lot of time. But by using these kind of services like Amazon SageMaker and all those machine learning services, all these are done very easily with some few clicks, and we'll be getting the output of the trained model with a better accuracy. So everything is made easy by using all those kind of services. So the point here to be noted here is that we have to have an idea of how to use the services and when to use that particular service. So that's what is nothing but the cloud, and that's what the certification exams cover also. So that's what is that. And under database you could able to see the service which is nothing but the RDS, which is rational database, and then DynamoDB, and all these kind of things comes under the database. And under computer networks, that is under the network and security, you could see the VPC, virtual private cloud, and elastic load balancer, which is to balance the number of requests, incoming requests, and it will be scalable by using the scaling groups, and by using the route 53. So all these kind of things comes under the network. So everything, there are a lot of services, but this is an overview of the categorization of the services I have shown in this picture. So this also depicts the same. You could see the deployment service, which is the cloud formation and code deploy. And under database, I've said RDS comes to play, and DynamoDB, then Redshift, and for networking, Route 53, VPC. So as you start to surf and learn by yourself, everything will register into your mind. So it's obviously easy if we just understand the working of all these services. So under compute, you could see the EC2 service and AWS Lambda. Lambda is nothing but the serverless. Serverless in the sense it doesn't mean it requires server. Actually, it actually requires server, but the name is serverless. Is that we don't want to think a lot about configuring those kind of servers. If we just run the code, every other setups will be done underneath the hood automatically. So we don't want to think a lot about managing those kind of and configuring those servers, and that's what's nothing but the serverless. And in AWS community builder community, as I'm under the serverless domain, I could just experience the value and the benefits of serverless, because it makes the work very easy. We don't want to configure anything, and if we just write or run the code, everything will be done accordingly by its own way. And that's what is nothing but the serverless. But the term serverless doesn't mean that it doesn't require servers. Actually, it requires servers, but we don't want to configure anything. That's what is the meaning of it. Because initially I thought that serverless means no servers are required. But now only I came to know that serverless also requires servers, but we don't want to configure anything. That's it. And next, coming back to, actually now we have seen the basics, and now I like to share something regarding the IAM as well as the storage service alone. So next, my friend Harish will take care of the compute as well as some kind of pricing stuff. So I'll just brush it up fastly. So now we are going to see about IAM. IAM is nothing but the identity and access management. So it's merely for the security purpose, because under one project a lot of people will be working, but everyone can't be given every access. So everyone will be given the least privilege, that is the required access for their working. So all these kind of security credentials, access, everything is managed under this kind of IAM service. So this is a key point to be noted here. It's for the security and for accessing the AWS services. Those kind of things are managed by this IAM. And now coming back to the storage service, and this is what the service which I'm going to tell about, tell all today. That's the today's focus. And the storage service, actually it's divided into like around seven types. That is S3, which is nothing but the simple storage, and EBS, which is nothing but the elastic block storage, and EFS is nothing but a file system, and Glacier. And this is what given in this picture, and we'll be just seeing the use of these kind of storage services. So initially, let's see about the S3. S3 is nothing but why it is called as S3 means it is simple storage service. So as S is a starting letter of these three words, it is called as S3 shortly. So the main use of S3 is that it's used to store the objects. That is anything we are storing, maybe the files of images or videos. Everything is stored as an entire object. So that is what the use of S3. And every objects are stored in the buckets. So in the computer we could see that a folder will be there, and under a folder a lot of files will be there. In the similar way, whatever objects we want to store, we'll be just storing in some bucket. We'll be just creating the bucket, which is the outermost layer. And by default, whatever we are just storing in that or private by default, but we could enable it to public if we wish so. And then further inside the buckets, we could create a lot of folders, and the objects, which is nothing but the files, could be stored inside the buckets. And that's what is the use of Amazon S3. And there are certain name conventions which must be maintained while creating the bucket. So the bucket name must be globally unique, because then only when we are retrieving some kind of data, no clashes will be coming. So the naming conventions is that it should include no uppercase and no underscore must be given, and the maximum character length must be up from 3 to 63. And the name which we are giving must not be an IP, as well as it should start with either the lowercase or number. These are the conventions which must be taken into account when creating a bucket. So as I've said, in our system will be telling us files, but in the cloud side will be telling us objects. So the objects are stored inside the buckets, and these buckets hold a lot of objects, and the object size can be from minimum size to up to 5 TB. And each and every object has two types of data, which is nothing but the system metadata, which is about the particular that is about the time of creation, all those kind of stuff. That is nothing but the system metadata and the user defined metadata. All these two kinds of metadata is maintained under the particular object. And this is how the console of the Amazon S3 looks like. So you could see the bucket names which is given under the first column, and the region where it is created is given in the second column, and the access, that is whether it is given as public access or private access, is also mentioned in this column. And the metadata, like when it is created, at what time it is created, all those kind of stuffs is mentioned in the last column. And this is how the console looks like. As far as time is concerned, I couldn't able to show you the AWS console. I have taken the screenshots to for the presentation purpose. So this is how the metadata of the file, that is the object which we have saved, gives the overview, like who is the owner and in what region it is created. And the main use of S3 is that we could handle the versioning, like if we have done any changes, and those kind of versioning control can be handled by using this kind of S3 service, and all those kind of metadata, everything is present here. And by using this, every object is assigned with a particular URL. So by this S3 URL, we could able to access the particular data. And if you have noticed, the leak code platform is even hosted by the S3. So S3 plays a major role in for storage in various platforms. So this is how the bucket versioning can be enabled or suspended. So it must be done manually by just either choosing this radio button. And when we are creating a particular object, we could fit those kind of things under either a storage class in any particular one of these. Actually, a standard is by default, it is everyone will be using. And the intelligent triading is that when we are using it often with the frequent access, it comes under the standard. But when we are just using it infrequently, automatically the life cycle, this process takes place and it will be shifted to the glacier. Glacier is nothing but the cold storage, so we will not be retrieving the data frequently. So those, if those kind of data can be stored in the glacier. And finally, deep archive, very infrequent data will be handled there. And there are other services like standard IA we will be using, but it is also infrequently accessed, so that comes under standard IA. And one zone is that it will be available in one particular AZ, not in all AZs. So that's what is nothing but the own zone. And now we have seen about S3. And next, I'll be telling you a small difference between what is EFS, which is nothing but the file system, and the block storage. So EBS is nothing but the block storage, which is concerned about storing the data as set of blocks, and EFS is nothing for storing the files. So EFS, the accessibility is regional, and for block storage, it is zonal. So data scalability, when it comes to data scalability, EFS can handle unlimited amount of data, whereas in the blocks, that is EBS volumes, it is of limited. So EBS volumes can be attached with the EC2 instances. So for beginners, it will be like a bit confusing, but after you have learned about the compute resources, you'll be getting a clear picture of how to use these kind of things. And this is to just to tell how the EF, that is files and the blocks of objects, can be stored. So for that purpose, EFS and EBS is used. And now, finally, I want to wrap up the session because I'm running out of time because he too has to handle. I'll just finish it with the benefits. So, coming to the benefits of the storage, it is very easy to recover the data and to for easy backup because it is available in multiple AZs. So, if some AZs goes down, we could retrieve the data from the nearby AZ in that particular region. It is used for data storage. It is used for data archiving. Archiving in the sense it is archiving is glacial. That is a S3 glacier. It's a storage class which will be storing the objects of infrequently accessed data, and is used for data transfer, and it is able to achieve the availability, scalability, durability, flexibility. All these kind of things are achieved only because of the storage. And the compliance capability is also achieved. So there are a lot of benefits under this kind of storage services. And in a similar way, as there is a storage domain, there are a lot of domains, and under each domain there are a number of services. In this session, I have just covered about what is basically is AWS and what kind of services are there, just as an overview. And then I have stressed a little bit on the S3, S3 EBS and EFS, which comes under the storage. And thanks for the patient listening. I like to hand over my session to Harish. Thank you. If you have any queries, you could just drop it out in the chat box. I'll be just dealing with it at the end of the session. Thank you. I'll just stop presenting. Okay, fine.
Okay, so good evening, guys. So now we'll be continuing with the compute section of AWS. So before starting the session, I'd like to welcome everyone for sparing time to join this session. So let me share my screen now. Let me share my entire screen. So that, okay, is my screen visible, right?
Yes, it's visible, and you're perfectly
Okay,
audible too.
okay. Is the slideshow visible?
Yeah, it's visible. Just check with changing the slides. Yeah, it's fine.
Yeah,
It's
changing, right?
working for you.
Okay. So, good evening, guys. So now we'll be seeing with the AWS pricing. So AWS actually offers you a pay-as-you-go pricing model. Like you will be only paying for the services what you are using, and for the amount of time that you are using the services. And you need not sign any long-term contracts or complex licensing with the AWS platform. And it's just like using electricity, right? Actually, you pay only for the amount of electricity or the amount of water that you use. So actually, you will be only paying for the services that you consume. And once you stop using the services, there will be no additional cost or termination fees. But checkpoint here is that you must not leave any service or instance running. Otherwise, they'll be charging for the entire amount of time it will be running. So that's what is the pricing. And now let us see how to interact with this AWS platform. Actually, with the cloud platform, the infrastructure becomes virtual, right? So you need not manage any physical servers, configure any servers at your workplace or on premise. You just like if you need a server, you can go there, and you can like wrap up for EC2 instance with your preferred operating system, preferred memory, preferred disk space. Yeah, so actually, everything becomes virtual with the cloud. But yeah, question which comes here is that how are we going to interact with this AWS platform? Actually, as everything becomes virtual, we need to logically manage the infrastructure instead of physically managing the infrastructure. All the physical management will be taken care by the cloud provider, which in our case is the AWS, and we need to just logically manage the infrastructure. So we'll be doing that with AWS application programming interface, which is an interface between the user and the AWS backend. So we'll be issuing API calls to the AWS API, through which we'll be configuring our server instances or any sort of service that we'll be using on AWS. Okay, so we'll be making this API calls in many ways. So, but we'll be focusing on these four important ways. Right? The first and the foremost is AWS Management Console, and the second one is the AWS Command Line Interface, and the third one is AWS Integrated Development Environment, and the last one is AWS SDK, which is the software development kit. So, let us now see the things in detail one by one. So the first one comes the AWS Management Console. It is actually a website. We can also term it as a web-based console. It actually comprises of a broad collection of services. So wait a minute. Let me show you the AWS Management Console. So you can just go to any browser and type AWS Management Console. And the first link which will be appearing is the AWS Management Console link. So let me log in. So this is the AWS Management Console, and here you can pretty much search any kind of service that you need. For example, as Kavya discussed, let us search the S3 service. Just if we type S3, it will be listing all the storage services, like CS3, S3 Glacier, AWS Snow Family. Yep, and yeah, you can pretty much open any service in this console, and you can interact with the service. Okay. In the AWS Management Console, we need not worry about any scripting or programming syntaxes. It's like a graphical user interface where we can interact with the AWS just by clicking or um, just with the help of GUI, we can access these services without any commands. And we can also able to select the region in which our AWS service to be in. So just if we head to this console, here we'll be having this region. So if we click this region, see there are many regions actually. So if I wish to change my region to like Asia Pacific, I can do that by clicking it. Sorry, actually it's not supporting. Yeah, actually, as it is a global service, it's I'm unable to change. Like I think I'll be able to change with the EC2. Yeah, now we can change. As EC2 is a region-specific service, we can change the region. See, first it was on North Virginia, and now we have changed to Mumbai. And yeah, and we can have our EC2 instance in pretty much any region in the world. Yeah, that's what with the AWS Management Console. And next, let's discuss about the AWS CLI, which is the command line interface. It's an open source tool that enables us to create and configure AWS services using commands in our shell. Like we'll be able to run this AWS command line interface in pretty much any operating system. Like if you use Linux, you'll be using Bash, or if you use Mac OS, you can use Z shell or TCSS. And in Windows, you can use command prompt or Windows PowerShell. And the another AWS CLI is AWS Cloud Shell, which is a browser-based shell. Let me show you the AWS Cloud Shell also. So if you head to the AWS Management Console form, yep, we have Cloud Shell here. So let us select the US region. And yeah, we have the Cloud Shell icon here, right? So the shell is loading. Yep, it's up and running. Yeah. So yeah, our Cloud Shell is uh, up and running, so we can pretty much work with any Linux commands here. So we can create an EC2 instance or an S3 bucket to this command line interface also. Okay, yeah, that's what we have discussed, right? We can script or program the API calls through the AWS command line interface instead of going to a graphical user interface. And next we have IDE and IDE toolkits. Like programmers will be using some sort of IDEs for coding, right? So, for example, you can take Visual Studio for C Sharp or Visual Studio Code for Python or some other languages, and for IntelliJ for Java and Python for Python. So AWS provides IDE toolkits which can be integrated with these IDEs, so that directly through the IDE you can contact the AWS platform through the program. Like if I have Python IDE, I can contact the AWS platform through the Python program. And at last, we have the SDKs, which will help us to interact with the AWS API programmatically. And these are some of the programming languages that AWS supports currently. For example, we have Java, Python, JavaScript, and so many other languages. And Swift actually is in developer preview. So these are some of the ways which we can use to communicate with the AWS console. Yeah. Any questions from the chat bot? Yeah. We can continue, right? No issue. And this is actually a case study where Netflix is a tech giant which is completely on AWS. Like Netflix has zero physical servers and they entirely use AWS. Netflix uses AWS for all its computing and storage needs, including databases, analytics, recommendation engines, video transcoding, and pretty much actually entire Netflix is uh, completely hosted and it's running on AWS. And Netflix uses more than 1 lakh EC2 instances on AWS. And AWS actually provides Netflix with, as we have discussed, compute storage and infrastructure. And it allows the company to scale quickly, operate securely, and meet capacity needs. That's what the beauty with the Netflix website, right? Netflix will never go down. If we see companies like Facebook or Instagram or Twitter, even WhatsApp suddenly going down due to server crashes. But actually, Netflix never goes down because it's completely hosted on AWS. And next, we shall discuss about the AWS shared responsibility model. Actually, AWS splits the responsibility into two, which is the AWS responsibility and the customer responsibility. AWS is responsible for security of the cloud. Security of the cloud, it means that the security for the physical infrastructure. Like AWS is responsible for protecting the hardware infrastructure that runs all of the services in the cloud. Actually, when we run any service in the cloud, we need compute instances at the back. So for maintaining all these servers securely, AWS is solely responsible. They do this by contracting out to companies which are 3 to 4 tiers below them. Like AWS never discloses their the exact location of their data centers to the outside world, right? So they'll be saying that there is a availability zone. Actually, they'll be saying like Mumbai is a region where we have three availability zones, but they'll be not disclosing the exact location of that availability zone. And the another beautiful thing is that the people who work in the data center of AWS actually they don't even know that they are working for AWS. That's the amount of security that they provide for the physical infrastructure of their servers. And then we have the customer responsibility, and customer is actually responsible for security in the cloud. Security in the cloud means that see if I have an AWS account, I must not just like that give my AWS credentials to anyone, right? As everything in the cloud is uh, money or cost. See, like if someone gets access to my AWS credentials, they'll be just like creating 10 compute instances, and if they left the instances running for a large amount of time, actually money will be deducted only from my account and not from theirs. So actually, and if we consider storage like S3 buckets, if we provide public access to some important S3 buckets, so the sensitive data might be leaked. So it for all these kind of things, only the customer is responsible, and AWS is not responsible for these kind of faults. So that's why they have splitted the responsibility model into two. Actually, the AWS responsibility and the customer responsibility. And as we have discussed, the customer is responsible for the configuration work as a part of the security responsibility. And this image is officially from the AWS documentation for the shared responsibility model. And as you can see, AWS is responsible for managing the hardware and the software in the physical infrastructure, and the customer is responsible for the customer data, operating system that they configure in their EC2 instances, their network and firewall configuration. Like if they didn't configure their firewall for their EC2 instance properly, it's the fault of the customer and it's not the fault of AWS. And this is the cloud market share in 2023, where AWS is currently holding 32% of the market share, which is uh, it's very huge numbers. And as you can see, uh, the cloud in the second place, Azure, which actually holds only 19%. and GCP has only 7% market share. And now let's discuss about the Elastic Compute Cloud, which is the EC2. Actually, EC2 and S3 are the finer services in AWS. Like when they started the Amazon Web Services, they offered these two services primarily, and only then all the services were built around these two basic services. Storage or S3 is for storing, and this is for computing and processing. And Amazon EC2, it provides secure, resizable compute capacity in the cloud, and it is designed for making web scale cloud computing easy for developers. And with the AWS free tier account, you actually get 750 hours per month for for the first 12 months with the AWS free tier account. And with this 750 hours, you will be able to run only one type of instance, which is the T2 micro. And we have a huge variety of processors, storage, networking, and operating system to configure our EC2 instances. And we also have the AWS marketplace from which we can purchase any pre-built Amazon machine image, which we'll be discussing in the further slides. So till this, any questions in the chat? Okay, fine. We can continue, right?
No, Harisha, there's no questions. I'm checking the chat box.
Okay, thanks.
Okay.
Yep. So we have the Amazon Mission Image. So these are pre-configured list of operating systems. For example, we have Microsoft Windows, Linux, such as Amazon Linux. Amazon actually have their own Linux backend, which is Amazon Linux. We have other famous Linux platforms also like Ubuntu, Red Hat Enterprise, CentOS, SUSE, and Debian. And the AWS Marketplace features a wide selection of commercial and free operating systems from well-known vendors. So next we have the EC2 auto scaling. Actually, auto scaling is nothing but when we have a high amount of traffic, automatically the number of servers will be increased. Like if you consider the Amazon website itself, right? During the Great Indian Sale, they usually have a very high amount of traffic in their website. So initially, if there are 100 compute instances in the normal days, and once the traffic gets increasing, the number of compute instances also will be increased automatically. And once the Great Indian Sale ends and once we get back to the normal days, so the additionally created compute instances, they'll be automatically discarded or deleted. So this is uh, uh, what I mean. This is the definition for auto scaling, and auto scaling is like dynamic or predictive scaling policies. So what meant by predictive scaling policies is that you can use machine learning algorithms to predict when your application will be receiving a high amount of traffic. For example, I can build a machine learning algorithm to auto scale my server such that if Diwali is occurring in the month of September or October, I can train my algorithm such that in the period of October to November, the number of services for my website it will be automatically scaled and it will be increased. And we have it will be established on real-time patterns also. Like real-time patterns means that there will be no predictive scaling. Suddenly, if we get a high amount of traffic, automatically the servers will be increased. So that's the real-time demand patterns. And using machine learning also, we'll be able to predict and schedule the right number of instances at the right time. Um, yep, that's it. Auto scaling. So any doubts with the auto scaling process? So shall we proceed? Okay, I think we can proceed. So next we have elastic load balancing. So load balancing is nothing but distributing the incoming traffic equally to all the instances. Like if we have 100 compute instances, it's not fair to send all the incoming traffic to only one compute instance, right? So load balancing will be doing the work of splitting the traffic and equally distributing the traffic to all the compute instances. And it also monitors the health of the targets and routes traffic only to the healthy targets. Like if we have some 10 to 20 servers, and if the 3 to 4 servers are down, so this load balancer will not send the traffic to the servers which are down. It will be sending the traffic only to the active servers. And that's what is the work of elastic load balancer. And using a load balancer increases the availability and fault tolerance of our applications. Sorry. And next we have the EC2 pricing. Actually, EC2 is free to try in the free tier account, because they are giving 750 of per month for 12 months. So actually, there are four types of pricing for these EC2 instances. They are the on-demand, savings plan, reserved instances, and spot instances. Also, we have dedicated hosts which provide EC2 instance dedicated solely for our use. So first, let us see about spot instances. So spot instances are nothing but actually there will be some free EC2 instances, and we'll be going and saying that I'm willing to give this much price for this instance. So the AWS will be providing that instance to us, so we can use that instance without any interruption. But if some other person comes and gives an amount higher than us for that instance, they'll be taking that instance and giving the instance to the person who bidded a higher amount than us. So till that we can use the instance without any interruption. So basically, we'll be setting a price for an instance, and if the price goes above the price which we have bidded for that instance, the instance will be automatically taken from us. So applications that have flexible starting and ending times, right? They can use the spot instances, because spot instances usually have very low compute prices, as only the customer fixes the price for the spot instances and not the AWS. So any doubt with spot instance pricing? Okay, fine. So next we have the on-demand instances. So with on-demand instance, we only pay for the capacity that we run per hour or per second. So if I'm running a server for 1 hour, right? So I'll be paying for 1 hour for running that compute instances. So uh, on-demand instances are usually recommended for the low cost and flexibility, and applications with short-term, spiky, or unpredictable workloads that cannot be interrupted. They'll be using this on-demand instances, because uh, if we go for the spot instances for these kind of applications, right? So at any time, the instance may be taken from us in the spot instances. But in this, we need the continuous execution of our server. So for these kind of workloads, we must prefer on-demand instances. So next we have the reserved instances. Reserved instances are nothing but the on-demand instances, but we'll be having significant discounts when compared to the on-demand instances. So, for example, we can consider I am building a website, and it's a new website, right? So I need to host this website and run in the internet for just 1 hour. So for this 1 hour, I can buy an on-demand instance and make my payment just for 1 hour. So I'll be charged only for that 1 hour that I am running my server. But in case of reserved instances, you can take an MNC, right? So if any MNC or tech giant like you can consider even Netflix. So Netflix is completely hosted on AWS, right? So a company like Netflix will be purchasing reserved instances from AWS. Like they'll be negotiating with AWS. Like we need this instance for 1 year. Like for 2 years, we need this set of instances. So AWS will be reserving that particular instance for the entire 2 years for Netflix. And even though if Netflix uses that server or not, they have to pay for that instance since the instance is reserved for them. So in reserved instances, we have three types: no upfront, partial upfront, and full upfront. So, for example, if I need to reserve 100 servers for my project, so you can assume you need to reserve 100 servers, and no upfront means I'll be reserving zero servers. Just I'll be telling AWS that I need 100 servers. That's what I'll be telling, and I'll not be making any payment. So partial upfront means in the 100 I'll be first reserving 50 servers, and I'll be telling them that you reserve these 50 servers for me, but I'll be taking that 50 servers in future. So what AWS will do in partial upfront is that they'll be giving me 50 servers, and another 50 servers they'll be lending in spot instances or some on-demand instances. And when I go and tell them that please give me those 50 servers also, so they'll be taking the servers from the spot and on-demand customers. So and they'll be taking and they will be giving to me. So full upfront is that if I need 100 servers, I'll be telling them that I need 100. So they'll be like giving that entire 100 servers to me, and I need to make payment for the entire set of servers in the starting itself. So that's what with the instance pricing. So if you have any doubts with the instance pricing, you can put in the chat box, or if you understood these pricing models, you can just give a thumbs up in the chat so that I can proceed with creating an EC2 instance. Okay, fine. So my screen is visible, right? Is my screen visible?
Yeah, it's visible.
Okay, fine. So let us go ahead now and create an EC2 instance. Okay, so let us head back to the AWS management console, and so this is the AWS management console, and here we can search as EC2. So we'll be selecting this EC2 service, and I'll be leaving the region as such in the North Virginia, or if you wish, you can change to Ohio region. So pretty much any region you can choose, but while choosing the region, please choose the region near to your location, right? So that there'll be less latency in the server. So actually, I have 0 instances running. So let me go ahead and launch a new instance. We'll just click on launch instance, and we'll be clicking launch instance again. So now we'll be launching an EC2 instance. So let us give our instance a name, Cloud Bootcamp. So we can add additional tags also if it is needed. So the default tag for the EC2 instance will be name. So we need not add the name tag. Actually, the instance name will be automatically added as the name tag. So let me add that. And coming to the EC2 instance name, you can pretty much give any name. Actually, there's no name conflict as in the S3 bucket, such that it needs to be unique. So, but the EC2 instance name must be unique within your own AWS account. You cannot have two instances running with the same name, Cloud Bootcamp. So this is the Amazon mission image that we have discussed in our presentation. Like they have a many set of operating systems, or you can browse more AMIs even from the AWS marketplace. So this is the AWS marketplace where they have many kind of operating systems. Like you can see AWS Linux, Mac OS, Red Hat, SUSE Linux, Windows Server, Windows Base. They have a very rich set of operating systems. So, but for now, we'll be using the Amazon Linux. Okay. So the instance type is T2 micro because only the T2 micro is free tier eligible. So if we go for other instance type, we have so many kind of instance types. Actually, we have special instance types for compute, for storage, for graphics processing. For each kind of application, we have a separate instance. So now let us go with the T2 micro, which is a free tier eligible one. And for connecting to our instance, we need this. We need to create a new key pair to connect to the AWS instance, which we'll be creating now. So let us create a new key pair and give it a name. So I'll just keep it as my name, and we shall leave the others as default, and let us create a new key pair. And this will be downloading a .pem file. So let us download it. Okay, the network settings also, if we need to create subnet, we can create, but as time is concerned, we shall leave the things as that. And if we need to allow HTTPS or HTTP traffic, we can allow. So for now, we shall allow HTTP traffic for our server. And here we can configure the storage for our server. So now we can add a 16 GB of general purpose SSD. Actually, here we have many types uh, of disks. Also, we have general purpose SSD. We have provisioned IOPS. IOPS is nothing but input output processing SSD, and we have throughput optimized, and we have cold HDD for using with the Glacier service, and we have standard magnetic disks also. So for now, we shall leave it as the default one. So if we need another volume also, we can add another volume. So let us add another volume of 8 GB. So the first volume that we are adding, right, it will be the root volume, and the other volumes that we are subsequently adding, it will be an EBS volume. So here we can see the summary of our instance, and here we can change the number of instances also. If I need two instances, I can go for two instances. If I need 100 instances also, I can do. But while increasing the number of instances, AWS directly will be recommending us to go for auto scaling instead of increasing the number of instances. Because if we create 10 instances, so we must pay for the 10 instances, uh, though we run them or not. But if we go for auto scaling, we'll be paying for the additional instances only when they are up and running. So in the rest of the time, we need to pay, we can pay only for the one instance which we have created. So let us leave the remaining details as such, and let us launch this instance now. And our instance is successfully created and it's up and running. So let us go to this instances page. So as you can see, we have our Cloud Bootcamp instance, and the instance state is still pending because the instance is still not created. So let us refresh ourselves. Yep, and our instance is up and running. As you can see, the instance state has changed to running, and we have the public IP address and private IP address for our instances. So the people, if you are from networking background, you'll be easily understanding like what public and private IP. So for others also, you need not worry much about these things. We'll be covering everything in the upcoming sessions, and you can see the all the details of your instances in this place. So now, if we need to stop our instance or like delete our instance, we need to select this instance and click this and terminate it. Sorry. If we wish to stop this instance, so we can stop the instance. Like if I'm running a compute operation and like in the night I'm going to sleep, so just I can stop my instance and go to sleep. So because if we stop the once we stop our instance, we AWS will not charge us for this instance, and only when the instance is up and running, they'll be charging for this instance. So once if I wish to start this instance again, I can just start this instance. Any doubts in the comments box? Okay, coming to free credits, me and Mr. Antakrish, uh, we are currently working on a way to get all of you free credits or sandbox environment to work. So if you are able to create an AWS account, you can create. Actually, AWS also accepts debit card as well as credit card. So if you have one, you can create and explore the free tier services. Uh, and in the meantime, we'll be also finding a way for getting you guys free credits or some kind of sandbox environment to work. So now let us terminate this instance as we have reached the end of this session. So in the upcoming sessions, we'll be seeing how to connect to a compute instance and how to use this public IP addresses to connect to our instance. So all the kind of things we'll be discussing in the upcoming sessions. So for now, I'll end my session, and if you have any doubts, you can ping in the chat box and yeah.
If there is any queries, you could ask now.
Apart from about the free tier account, if there are any other queries, please feel free to go ahead. We are currently working on that. Like Azure, for Azure, we have figured it out, as I told that by using the data that we are getting. For AWS, we still need some time as we are figuring out how to make it for all of you, because for AWS we got a lot of registrations. That is one of the problems. But yes, we'll definitely get back to you latest by Friday, as I told that we can have a project session on Friday where you can have a discussion with the mentors also about what kind of projects they will be breaking for you all. So yeah, and of course, as Kavya was saying, that is one of the ways that you can just register by for the free tier. That is also one of the ways if you are really eager to try things out. So thank you so much, Harish and Kavya, for taking time and answering our questions with your US basics. It was an amazing session. Even I got to learn some great things.
Thanks for the opportunity, and actually, it's because of you. You made it's possible, and
Yeah.
thanks for giving us the opportunity.
Yeah.
Okay, perfect. So, guys, any other things you would like to ask? Please feel free to go ahead, maybe, or else we will end the session.
Yeah.
You know,
Yeah.
so,
Thank you so much for your feedback. Yeah.
Thank you all.
So yeah, thank you so much everyone for joining. I think really an interactive one. Perfect. Thank you so much. And we will meet again for another session, exciting session, and let's see. In fact, I think tomorrow we can just have no need of session only. We can just have like a normal catch up meet. Yeah, I don't know. That would be much easier, right? Everyone will be more excited and interactive over there. So yeah, no need of meet only. We will just hang out the entire day over here on air meet. So perfect. Thank you so much. And bye for now. Thank you so much, Harish and Kavya, for joining.
Yep. Thank you
Thank you.
so
Thank you.
much
Thank you.
for this opportunity.